For the objectives, explain how managers of firms that operate in oligopoly markets can use strategic decision making to maintain relatively high profits. Understand how the reaction of market rivals influence the effectiveness of decisions in oligopoly markets. So here are the characteristics. If you notice, it looks a lot like monopoly. The only difference is it's a few sellers instead of one, right? There's blockaded entry and exit, just like monopoly. Imperfect dissemination of information, right? Cost, price, and product quality information are withheld from uninformed buyers. I would say from rivals also. And in general, it's a homogeneous or unique product, although you can relax that last assumption slightly, where they produce heterogeneous products. They're characterized by interdependence and the need for managers to explicitly consider the reactions of others. Unlike monopoly, who's the only one in the market, and don't have to worry about competitors, and those of imperfect competition or monopolistic competition, which simply are price takers, oligopolists really have to worry about their competition because their competition affects the price and, of course, their profitability. In general, they're protected by barriers to entry, sometimes from government fiat regulations, etc. Economy to scale, similar to a natural monopoly, or control of specific resources. The market's characterized by a small number of firms, and in general, they tend to encourage cooperative behavior if it's legal. And if they're able to collude and nobody cheats, and that's the big qualifier, nobody cheats, they can increase profit, decrease uncertainty, and raise barriers to entry. Basically, collectively, what they end up doing is acting like a monopoly. So the first model we're going to talk about is that collusion, sometimes known as a cartel. Cartels and collusion in general are illegal in the United States. Cartels maximize profits, just like a monopoly, by restricting output to a level where the marginal cost of production of every firm is equal to the market's marginal revenue. And then they charge the market clearing price, again, like monopoly. The need to allocate output among member firms results in an incentive to cheat by overproducing and therefore increasing your profits. But if everybody does that, of course, they end up lowering everybody's profits. We'll talk about that later. So here's our graph. As you can see, it's a monopoly graph, right? I have marginal cost, marginal revenue, where they meet, determines the quantity, and from that point, I go up to the demand curve, and that gives me the price. I have monopoly quantity and price, which gives them monopoly profits, and they just divide that monopoly profit in between themselves, depending on different factors like market share. But there's an incentive to cheat because by producing a quantity of output that exceeds the quota, right, a firm can increase its profits. Here's a basic monopoly graph. So here, B, right, is a quota where marginal cost equals marginal revenue, right? But B at that point is basically the costs, the total cost for the firms in the industry. Actually, B times Q1 is Now, taking that, right, if somebody cheats, say somebody produces a little more, well, the price gets lowered below P1 and out past Q1. And profits decrease for everybody except for that person who cheated. Questions? Okay. That's a cartel. Basically, all the firms in the oligopoly act as a monopolist. They get together, they charge the monopoly price and quantity. They don't compete with each other. And then they divide the profits in between them. There's an incentive to cheat, so cartels a lot of the time fail because there is that incentive to cheat, and it's hard to police. The next model I want to talk about is something known as price leadership. This is where you have one firm in the oligopoly that sets the price, and all the other firms follow. Many times it's that you have one big firm and a bunch of small firms. Firm sets the price and the small firms follow. But that's not necessarily the case. So here's some assumptions for price leadership. There's a single firm that sets the market price. There are follower firms that behave as price takers. In other words, whatever the the price leader sets, they take, and then they go ahead and set the price equal to their marginal cost. Once the price leader sets the price leader faces the residual demand curve. What that means is whatever price he sets, all the other firms will go ahead and sell as much as they can up to the point where price equals marginal cost for them. And then what's ever left over at that price, the price leader sells.
The price leader what?
I'm sorry?
You said the price leader what?
He sells what's ever left over. He sets a price.
Okay.
Firms sell as much as they can up to the point where marginal cost equals price. And whatever is left over, demanded at that price, the price leader sells.
Oh, okay.
The price leader produces a quantity at which the residual marginal revenue is equal to marginal cost. I'll explain what the residual marginal revenue is on the graph coming up. That's the price to clear the market. Okay. Here, this dotted purple line is the market demand curve or the industry demand curve. The blue line is the supply curve for all of the other firms combined. M, this upward sloping yellow line, is the marginal cost of the leader firm. And the residual marginal revenue is this downward sloping yellowish line. And I'll tell you how that's derived now. Okay, suppose the leader sets a price of P1. Well, at P1, right, the other firms are going to supply S1. This is a supply curve for all the other firms combined, and that's basically for them where their price, the price equals their individual marginal cost curves. S1. And what the leader firm is, it sells the difference between S1 and D1. And D1 would be the total amount demanded at P1 at that price, right, for the whole industry. So the difference between D1, right, and S1 is going to be what the leader firm sells, which is Q1. So if I took from 0 to Q1 and moved it over here from S1, it would go up to D1. It's what's left over. Now, this other downward sloping purple line is the residual demand curve or the demand curve for the leader firm. And the way they take that is, or the way we derive that, is we pick another price. In this case, let's say we pick P0. 0, right? All the other firms combined will sell R0, right? Where that intersects the supply curve for all the other firms. Again, where the price equals their individual marginal costs, they sell R0. The total amount demanded at P0 is V0, right? So the difference between V0, right, and R0, the leader firm would sell at that price, P0. That difference is little d0. So if I took V0, subtracted off R0, it would be the distance from 0 to little d0 here. And that gives you the price at P0. If I do that for all the subsequent prices, line right here, which is the residual demand curve. And from that residual demand curve, we get the residual marginal revenue curve, just like we would with any other downward sloping demand curve associated with its marginal revenue curve. Okay. Here is basically what I just told you, right? The demand curve for the leader, D, is derived as follows. If they set a price other than P1, for instance, P0, the small firms, the follower firms, right, will supply R0, where it intersects the supply curve. The rest will be supplied by the leader, right, which is the difference. It's V0 minus R0, which is little d0. So little d0 will therefore be the point on the leader's demand curve. And I do that for every subsequent price. Therefore, I get the demand curve for the leader, which is called the residual demand curve. Questions? Okay. Well, that's the most complicated part of the lecture so far. We have one more complicated spot. The rest, I think, is pretty straightforward. Now I want to talk about duopoly markets. And the reason we do duopolies is simply because it's simple, right? If we have an oligopoly with 3 firms or 4 firms, it's more complicated than analyzing an oligopoly with only 2 firms. And that's what a duopoly is an oligopoly with 2 firms, right? So we have this duopoly. We're going to assume that the firms produce an identical product. Managers make the decision simultaneously. Price competition, if they have it, tends to drive down price to marginal cost, and so should be avoided by managers. By the way, we're going to talk about the Bertrand model in a while. That's basically the basic Bertrand model, is 2 competitors just outbidding each other, driving down the price. Okay. Now, in our example for our duopoly, I'm going to assume I have 2 firms, and both firms have the same total cost curve. That is 500 plus 4 QI plus 0.5 QI squared, where QI is the amount they supply to the market, each firm. I'm going to assume market demand or the inverse demand is equal to 100 minus Q. And of course, since I have 2 firms, I can write that as 100 minus QA. We'll call them firm A and firm B. So 100 minus what firm A produces minus what firm B produces. And that's our market demand. So if our total cost is this, what's our marginal cost? It's actually down here, but you didn't have to look at that because you looked at the total cost and you took the derivative. You had 4.5 times 2 QI or just QI. So marginal cost is equal to 4 plus QI for both of the firms. Both have the same total cost, therefore they have the same marginal cost. Questions? Okay.
You said that the derivative
Yes, you take the derivative of the
Mhm.
total cost curve, of the total cost function. It's right here. See? You see the little arrow, Glorimar?
Yeah.
Okay. So 500 plus 4qi plus 0.5 qi squared. I take the derivative of this function, right? There's no qi here, so that's 0.
Yeah.
The derivative of that is just 4. 0.5 qi squared, the derivative of that is 2 times 0.5, or 1 qi. So the marginal cost is just 4 plus qi.
Yeah.
Okay.
Yes.
Okay. Okay. So what I want to do, right, initially is go ahead and look at that basic Bertrand model. Your book doesn't call it that, but that's what it is. Where price gets driven down to marginal cost. So for firm A, set marginal cost equal to price. So I go ahead and plug that into the residual, excuse me, to the inverse demand curve, market demand curve, and I solve for QA. So I have QA on both sides. I solve for QA, and I get QA is equal to 48 minus 0.5 QB. That is firm A's reaction function. In other words, whatever QB produces, firm A is going to follow this equation. So if QB produces, let's say 40 units, 40 units times 0.5 is 20, 48 minus 20 is 28. So if QB produces 40 units, firm A will produce 28 units. Now we do the same thing for firm B and we get the exact same answer because they have the same marginal cost. I set marginal cost equal to price, the inverse demand curve, and I get QB is equal to 48 minus 0.5 QA. Now, to solve for the quantity they both set, I can go ahead and plug QA, or my reaction function for QA, for firm A, into the reaction function for B. In other words, I just plug in, right, minus 0.5 QB, right, in here. So I get 48 minus 0.5 times 48, minus 0.5 times 0.5 QB. Does that make sense to everybody? I'm going to write it down. The problem is that I realized that today that when I do it for the camera, it's backwards. So I'm going to ask you to be a little dyslexic today and basically read the graph backwards. Sorry, I made a mistake. Really quickly. So that's why it's taking so long. But here it is. You're going to see some scratch outs. But here we go. Okay. So actually, so I can see it myself better. Sorry. Okay, I know it's backwards, but here I start off with QB equals 48 times 0.5 QA, and we know the reaction function for QA is 45 QB. Okay. If you look in a mirror, you might be able to read this. So QB.
It isn't backwards.
Huh?
It isn't backwards
for you guys?
No.
No.
Oh, I look at it as backwards. Okay, perfect. So QB equals 48 minus 24 plus
0.25.
0.25 QB. I isolate the QBs and I get QB minus 0.25 QB equals 24, or 0.75 QB equals 24. I divide both sides by 0.75, and I get QB equals 24 over 0.75, or 32, which is
QB and QA.
which is what the lecture says it should be for QB. Okay. So QB equals 32. I do the same thing for QA. That'll equal 32. I plug that into my inverse demand curve. 32 plus 32 is 64. 100 minus 64 is 36. So price is 36. They produce 32 units each, and each firm in this case earns a profit of $12. Now, even though they're charging a price where marginal cost equals price, the demand curve is still downward sloping, so it's still possible for them to have a profit and be above the average cost curve, since they don't have any entrants, right? Lowering the price in this case. Okay. Questions?
No.
Okay. All right. The next example is an example of collusion. Just basically what we did before. In this case, right, they go ahead and collude and charge the monopoly price. But to do that, what we need is marginal revenue. And here for marginal revenue, I just set Q, total Q, and I multiply P times Q. So I'll have 100Q minus 2Q, I'm sorry, minus Q squared. I take the derivative of that, and I get marginal revenue, which is 100 minus 2Q. Everybody follow that?
Yeah.
No, because isn't 100 a constant, and therefore if you take the derivative, isn't it supposed to be equal to 0?
Remember, I'm taking total revenue first. I'm multiplying P times Q. So I got P times Q.
So with respect to Q.
Is equal to 100Q.
Oh, okay, I see. Yeah,
Minus
and since 100Q and Q is the constant, Q
Q
is
squared.
equal to 0.
Okay.
Okay.
Well, since I already wrote it down, I'm going to go ahead and show everyone. Okay. Where'd it go? Oh, I got my hand over it, don't I? Okay. So Q times P equals 100Q minus Q squared. I take the derivative of that, and I get 100 minus 2Q. Okay. Okay. So that's our marginal revenue. The marginal cost for each firm where we did is 4 minus Q1. So what we need to do here is take a horizontal summation of the marginal costs. So if I solve for Q, QA and QB, I'll have, excuse me, I'll have QB, or QB equals marginal cost of B minus 4. For QA, I sum those two, and I get QA plus QB is equal to -8 minus 2 MC. I can go ahead and call QA plus QB big Q. So the horizontal marginal cost is going to equal 4 plus 0.5 Q. Right? Setting marginal cost equal to marginal revenue, right? And solving for Q, I get a Q of 38.4. If they divide it equally, each firm produces 19.2, price of 61.6. In this case, total profit is $843.20, and each firm makes $421 and change. Right? So colluding is much better than competing with each other, especially if you compete to the point where marginal cost equals price. Of course, as we said, there's incentives to cheat. Okay. Questions? Okay, I could have sworn I had put this table or moved this table, but since I showed it, let's go ahead and do the next example, or start with the next example using this table. I'm going to assume I have two firms, firm B and firm A. If firm B produces 0 units, then firm A is going to produce 32. If firm B produces 50 units, then firm A is going to produce 15.33. And finally, if firm B produces 96 units, then firm A isn't going to produce anything. They're going to exit the market. Okay. I wanted to show you guys this first, but here it is. If rivals make simultaneous decisions, have the same estimate of market demand, and have the same estimate of others' cost functions, and assume the other firm's level of output is given. That's an important thing, is I assume that what I do is not going to affect the other firm, or is not going to cause them to react. So in this case, if I'm a monopoly, right, and I'm firm A, I go ahead and I set marginal revenue equal to marginal cost, and I get a Q of 32 and a price of 68, right? And if I look at my firm, if firm B is 0, I produce 32. In other words, if firm B is not there, firm A produces 32. Okay. Now, if firm B produces 96 units, right? The residual market demand for firm A, P minus 4QA, right? That's basically 0, and QA produces 0. So therefore, firm B produces 96. And finally, if firm B, right, produces 50 units, the residual market demand for firm A is 50 minus QA, or 15.33. Questions? Hopefully it becomes a little more straightforward as we go on. So the next thing I want to do is go to a next example that's known as our Cournot example, which has the basic assumptions that I just talked about, is where I assume that what I do doesn't affect what the other firm does. I have the same market demand, P equals 100 minus Q, or for each firm, 100 minus QA minus QB. If I take the marginal revenue solely for firm A, I basically want to multiply my market demand times Q of A. So I have B Q of A equals 100 QA minus QA squared minus QB QA. And when I take the derivative of that, which is the marginal revenue for A, I get 100 minus 2 QA minus QB. Okay. I know that's hard to follow with me speaking, so. Okay. So my handwriting is horrible. I apologize. So total revenue for firm A, right, is simply price times Q of A. And multiplying that by the inverse demand curve, I have 100 QA minus QA squared minus QB QA. I take the derivative of that to get marginal revenue, and I get 100 minus 2QA minus QB. And that's the marginal revenue for firm A. Okay. The marginal revenue for firm A, the marginal cost for firm A is 4 plus QA. I set marginal cost equal to marginal revenue. In this case, 4 plus QA equals 100 minus 2 QA minus QB. This is marginal revenue. And I solve for QA, and I get QA equals 32 minus 1/3 QB. Right? That is firm A's reaction function. So whatever QB produces, firm A is going to produce whatever that number is, right here. So if firm B produces 30 units, 30 times 1/3 is 10. 32 minus 10 is 22, so QA would produce 22. Since firm B's identical, they have action function, just switch the A's and the B's. So I have QB equals 32 minus 1/3 QA. I go ahead and plug in one into the other. I plug in this equation right here for QB. I solve for QA. I'll get QA equals 24, right? And of course QB equals 24. So that would give me a price of 100 minus 24 plus 24, or 48, and a price of 52. And that would give me a Cournot profit for each firm of $364. Now notice that the Cournot solution is better than the Bertrand price cutting solution, where both firms just cut price until they reach the point where price equals marginal cost. But
what is a Cournot solution?
I'm sorry?
What is a Cournot solution?
It's this solution right here on the page, where QA equals QB equals 24, price equals 52, okay, and profit equals 364 for each firm.
Okay.
So as I said, the Cournot solution is better than the competition solution, but not as good as the collusion solution. And here's a graph, right, that shows both firms' reaction functions and where they meet. So here's firm A's reaction function, firm B's reaction function. Oh, I'm sorry, the axes. On the vertical axis, I have the quantity that firm A produces, and on the horizontal axis, I have the quantity that firm B produces. And in between, right, I have, excuse me, in between, right, where they intersect, I have the equilibrium Cournot solution, which is 24 and 24. Okay. Questions? Now remember what we have so far. We have a situation where they compete. They basically keep cutting each other until they reach price equals marginal cost. I have the collusion or cartel solution, and I have a Cournot solution where each firm believes that whatever they do, right, is not going to affect the other firm. In other words, the other firm isn't going to react to what I do, and they both believe that, and they act simultaneously. Questions so far? Okay. Now, what if there's more than two firms in a Cournot scenario? Well, we can go ahead and do that or analyze that. So I have P equals A, an intercept, before it was 100, minus some coefficient. Before it was 1. Times the summation of QI. Again, we're assuming they're all equal size firms, so we'll have the same coefficient. So it'll be QAB times QA plus QB plus QC plus QD and so forth for how many ever firms we have. Marginal revenue for the market is as follows: A minus N plus 1, right, assuming there are N firms, right, times B times QI. Marginal cost for each firm is C plus E QI. So notice we have actually 5 coefficients. I have A, B, C, and E. 4. I don't have a D. Okay. So I go ahead and set marginal cost equal to marginal revenue, and I get C plus EQI is equal to A minus N plus 1 BQI. Did I have a question? Okay. And I go ahead and I solve for QI, and I get QI is equal to A minus C divided by N plus 1 times B plus E. And that should be a big N, by the way. It's the same N as this one. Table, if I assume some numeric values for A, C, B, and E, right, I can see what happens to profits and price and quantity as the number of firms increase in the Cournot scenario. So I'm going to assume A is 100, B is 1, C is 4, and E is 1. So as I add more and more firms, we're going to see that price decreases, quantity increases, and profits decrease. So here, if for a cartel, right, their profits are 421 each. If there are 2 firms under the Cournot solution, their profits are 364. That's the example we had. If they add 1 more firm, profits drop to 52.96. Now, under the Cournot scenario, where both firms act simultaneously, if there are 4 or all firms act simultaneously, if there are more than 4 firms, 4 or more firms, profits become negative. At 4 firms, they have negative $116 in profits. They have a loss. And as more firms increase, that loss increases. And of course, if we have an infinite amount of firms, profits are negative 500. Questions? Okay. We talked a little about leadership before. Now we're going to talk about a specific type of leadership model called the Stackelberg model, where one firm gets to move first. So in the Cournot environment, right, if one firm moves first and optimizes production based on the rival's reaction function. So if I know my rival's reaction function and I'm able to move before them, I can set a quantity that's going to maximize my profits, and in almost every case, lower the profits of my rival. So here we have the same market demand, 100 minus QA minus QB, the same marginal revenue for firm A that we had before, and marginal cost for firm A. The reaction functions, therefore, will be the same for both firms. Firm B's reaction function, it'll be just like before, 32 minus 1/3 QA. Setting marginal cost equal to marginal revenue, right? Given QB's reaction function, so I set marginal revenue equal to marginal cost, substituting right here where I have a QB's reaction function. So now, mathematically, all I have is QA in the equation, and I just have to solve for QA. So marginal cost will equal 4 plus QA, and that'll equal marginal revenue, which is 100 minus 2 QA minus QB, where I substitute QB's reaction function, and I get 32 minus 1/3 QA there. So I solve for QA, and I get QA is equal to 27.43, right? if I take that 27.43 and plug it into QB's reaction function, QB is going to produce 22.86. So in this case, when firm A gets to move first, they produce 27.43, and B produces about 5 units less, 22.86. A's profit will increase from the basic duopoly Cournot solution to $377.71, and firm B's will decrease a lot more to $283.67. Right. So the first mover advantage for firm A, right, is worth $13.71 to firm A. Of course, firm B loses a lot more, so it would actually be, if you had some kind of game theoretical model, in firm B's interest to have Cournot, to have firm A, right, either not move first or pay them more than $13.71 to set a different quantity, or to set the simultaneous Cournot quantity. Did that make sense to everybody? Do you guys want me to write any of this down? Okay, I'll take your silence as a no. We're going to do the same Stackelberg type model, but this time I'm going to assume that firm A has lower costs. I'm going to assume that their cost function is 500 minus 0.5 QA squared, which is exactly as it was before. But I'm assuming that now QB's cost function has changed slightly, has increased. So now it's 500 plus 10 QB plus 0.5 QB squared. In other words, instead of 4 QB, it's now 10 QB, which increases their costs. I go ahead and take their reaction functions, setting marginal cost equal to marginal revenue for both firms. And firm A's reaction function is the same as before because their total cost function hasn't changed. B's reaction function, since their cost function has increased, is now different. It's 30 minus 1/3 QA instead of 32 minus 1/3 QA. So I plug in one reaction function into the other. Firm A goes first, right? I'm sorry, if firm A goes first, I want to maximize their profits. Plugging in B's reaction function into my marginal cost equals marginal revenue equation, I get a price of $51.14. 28 units, a little more than 28 units. Its profit will be $433, while QB's will produce 20.57 units, and their profit will be $134. Right? Now, what if firm B, as the higher cost firm, gets to move first? Well, I do the same thing. I take the marginal cost of B, right, which in this case will be 10 minus QB, instead of 4 minus QB as it was before. I set that equal to QB's marginal revenue, plugging in firm A's reaction function into the marginal revenue formula, and I solve for QB. And I'll get QB is equal to 24.87 down here. QA will produce a little bit less, 23.714. But since they have lower costs, their profits will still be greater. It'll be $343.55, whereas the profits of firm B will be $22.857. Questions? So, first mover advantage in a Stackelberg model has an advantage. It increases your profits, whether you're a high-cost firm or a low-cost firm. And of course, being a low-cost firm increases your profits over being a high-cost. Okay, questions? Okay, the next thing I'd like to talk about is the Bertrand model. As I told you, that cutthroat competition where marginal cost equals price is the basic Bertrand model. Here I'm going to assume that I have two producers who sell a differentiated product. Remember when we did our assumptions for oligopolies, we said that they sold a homogeneous product. So here we're relaxing that assumption a little bit, and we're allowing to sell a heterogeneous product. In other words, with differentiation. I'm going to assume that their marginal cost is 0, that the demand for firm 1's product is equal to 100 minus 3P1 plus 2P2. By the way, since this is plus, are these two firms producing two products which are complements or substitutes?
Substitutes.
Substitutes, perfect, because they're positively related. Okay, and firm 2's, the demand for firm 2's product is 100 minus 2 plus 2P1. So from that, what I'm going to do is for firm 1, I'm going to go ahead and multiply function by P1, right? And that'll give me total revenue. So I'll get total revenue P1 times 100 minus 3P1 plus 2P2, or 100P1 minus 3P1 plus 2P1P2. In your book, what it does is it breaks that into 2. Now notice we're doing something a little different here. Instead of taking the inverse demand function, we keep the demand function and multiply it by P, instead of taking the inverse demand function and multiply it by Q. And the difference will become obvious a while ago. So here, our marginal revenue, or what your book called marginal revenue, is going to be, right, the change in revenue relative or with respect to a change in price and not a change in quantity. Anyway, given this total revenue firm, I can divide total revenue into TR11. In other words, just that part of total revenue that only depends on the price of good 1, and TR12, which is that part of total revenue for firm 1 that depends on both the price of P1 and the price of its rival product, P2. So here TR11 is equal to 100P1 minus 3P1 squared, and TR12 is equal to 2 times P1 times P2. Questions? Okay. So now I take the marginal revenue, in this case with respect to P1, and I know that's not the definition that we've been using, but this is what their book does, so I'm going to keep it. I'm going to keep the terminology the same. So I can write the marginal revenue for firm 1 with respect to P1 as the change in TR11 over the change in P1 plus the change in TR12 with respect to the change in P1, or that means marginal revenue is going to equal 100 minus 6P1 plus 2P2. Now to get the reaction function for this firm, I set marginal revenue equal to marginal cost, this marginal revenue. I set that to marginal cost, which in this case is 0. So I set marginal revenue equal to 0 and solve for P1. And I'll get P1 is equal to 50 divided by 3 plus 1/3 P2. That is firm 1's reaction function in terms of price in P2. So when P2 increases, right, the price of P1 will increase. That's a reaction function. Right? So continuing with that, I get a similar reaction function for firm 2. 100 minus 6 in P2 plus 2P1 equals 0. I get P2 is equal to 50 divided by 3 plus 1/3 P1. So basically, in the reaction functions, all I have to do is change the 1's and the 2's to get each firm's reaction function. I plug in the reaction function for P1 into the reaction function of firm 2. So I'll just plug it in here. And I solve for P2. And I'll get P2 is equal to 25. I do the same thing for P1, and I'll get P1 is equal to 25. Okay. I can plug in values, 25 plus 25, into each firm's demand function, and I'll get the Q for each firm, and that'll be, I plug in 25 here and 25 there, I get a Q1 of 75, and I do the same thing here, and I get a Q2 of 75. Symmetrics, that's what I get. So Q1 equals Q2 equals 75. I go ahead and solve for profits, and I have profit of firm 1 having the same profit of firm 2, which is equal to $1,875 under the Bertrand model when they move simultaneously. Questions? Okay. And here are the reaction functions, right? Where I have the price for firm 1 on the vertical axis and the price for firm 2 on the horizontal axis. They both increase, right? And where they cross each other, right, is the equilibrium price for these two firms, which is 25 units. I'm sorry, $25. Questions? Okay. So now what's the total revenue for both the firms? To get that, I just substitute the total revenue for both. So I'll get TR11 plus, TR11 plus TR22 plus TR12, which equals 100 P1 minus 3 P2 plus 100 P2 minus 3 P2 plus 4 P1 P2. Remember, that's not 2 because we do it twice, 1 for each firm. So marginal revenue for firm 1 is simply the change in total revenue with respect to the price in P1, which is 100 minus 6 P1 plus 4 P2. And do the same thing for firm 2, and I get marginal revenue for firm 2 is equal to 100 minus 6 P2 plus 4 P1. Using that to get reaction functions, in other words, plugging one marginal revenue curve into the other, set it equal to marginal cost, I get P1 is equal to 50 minus 3 plus 2/3 P2 equal to marginal cost equaling 0. And do the same thing for firm 2, as P2 equals 50 divided by 3 plus 2/3 P1. Now notice the reaction functions here are slightly different, right? Instead of being 50 divided by 3 or 1/3 P2, it's a plus 2/3 P2, right? So I solve those reaction functions simultaneously, plugging one into the other, and I get P1 equals P2 is equal to 50. Plugging it into the demand curves, I get Q1 equals Q2 equals 50. Okay, profits increase, right, to $2,500, right? Okay. Again, so colluding or merging is always adds up to more profit, assuming, again, nobody cheats. Anybody have a question?
Nope.
Okay.
Nope.
I told you it was going to be a short, excuse me, a short lecture, and that's it. Okay, since there's no questions, I'd like to